Hello everyone. In this lesson, we will be talking about binary operations. An operation is performed on something. A binary operation requires two inputs. It is also a function. Let's say we have a function f which takes the input as x, y and returns the output x plus y. So this is a binary operation because it takes two inputs and gives an output. There are many binary operations, some of which you already know, like the plus operator, the minus operator, the multiplication operator, and the division operator. The plus operator can be written in this form plus 2, 3, which gives 5. Similarly for the other operators. Okay, now let's properly define a binary operation. A binary operation on a set A is a function from A cross A to A. This is the Cartesian product. This can be written as A comma B gives this. Now A and B should both belong to the set A and even the output should belong to set A. This asterisk symbol can be replaced by any of the binary operator you know, like plus, minus. Since the output should also belong to the set A, you must be a little careful. Let's say we define the minus operator on the set of natural numbers. If I take 3, 2, you will get 1. It belongs to the set of natural numbers. But if I take 2, 3, it will be equal to minus 1, which does not belong to the set of natural numbers. Therefore, the minus operation on the set of natural numbers is not valid. The division operator cannot be defined on the set of real numbers because if you take b as 0 and a as any other number, you will get a by 0, which is not defined and it does not exist in the set of real numbers. Therefore, this is not possible. But if you limit the set A to the set of real numbers minus the element 0, then this operation is valid because then b cannot be 0 and so there will be no division by 0 and therefore a by b will be valid. It is important to know that the plus, minus, multiplication, division operators, they are just symbols. If someone defines a function like this, then the function applied on 3, 2 will result in 1. But conventionally, a plus b is equal to the addition of a and b. We can explicitly change their purpose if we want to. When someone writes minus 1 or minus 5, this is not an operation. It is just a symbol that indicates that the number is negative. Now, we will discuss some properties of a binary operation. First, the commutative property. A binary operation is said to be commutative if A asterisk B is equal to B asterisk A. Let's take an example. The addition operator 2 plus 5 is same as 5 plus 2. Similarly for the multiplication operator. But for the minus operator, 2 minus 5 is not equal to 5 minus 2. Therefore, the minus operation is not commutative. Even the division operator is not commutative as A by B is not equal to B by A. The associative property. A binary operation is said to be associative if A asterisk B asterisk C is same as A asterisk B asterisk C. The plus and multiplication operator are associative as 2 plus 3 plus 5 is equal to 2 plus 3 plus 5. And similarly for the multiplication operator. But the subtraction and the division operator are not associative since 2 minus 3 minus 5 is not the same as 2 minus 3 minus 5. Similarly, you can see for yourself that the division operator is not associative. If a binary operation is associative, writing this statement makes sense. You can have as many variables and you will be able to calculate the final value. But if it is not associative, the value of the output will change based on what part of the statement you calculate first. Now, I will explain to you what is an identity for a binary operation. An identity is an element E which belongs to the set A. It must satisfy the following conditions. A asterisk E should be equal to E asterisk A, and both of them should be equal to A, where A belongs to set A and asterisk is the binary operation performed on the set A. For the plus operator, the identity is the element 0. If A is the set of real numbers, then any element added to 0 is the element itself. And since addition is commutative, 0 plus A is equal to A as well. For the multiplication operator, 1 is the identity. Since anything multiplied with 1 results in the number itself. The minus and the division operator do not have an identity because they are not commutative. So A asterisk C will never be equal to E asterisk A. Please note that A is the set of real numbers. If it was a set of natural numbers, then the identity on the plus operator cannot have 0 because 0 is not a natural number. So the plus operator does not have an identity on the set of natural numbers. This statement should be valid for every element A belonging to the set A. Only then we can call E as the identity. If an identity exists for the binary operation, then an element A belonging to the set A is said to be invertible if there exists another element B belonging to A such that A asterisk B is equal to the identity element of the set A and that is equal to B asterisk A as well. If this condition holds, then B is called the inverse of the element A and it can be denoted like this. So, for example, if we take the plus operator, for any element A belonging to the set of real numbers, there exists an element minus A such that A plus minus A is equal to 0, which is the identity for the plus operator, and this is also equal to minus A plus A. Similarly, for the multiplication operator, A into 1 by A is equal to 1, and this is also equal to 1 by A into A. This does not hold for the element 0 because 1 by A will not be defined. So the element 0 does not have an inverse with respect to the multiplication operator. The elements with respect to the subtraction and division operator will not have an inverse because they are not commutative. So A asterisk B will not be equal to B asterisk A, and secondly, they don't have an identity. This is it for this lesson. Thanks for watching.